So some students ask me, when we try to evaluate sine of negative 13 pi over 4, then we get the sine of pi over 4. Then she asked me, where this 13 go? Actually, we use the reference angle to evaluate this sine value, right? So we first divide 13 by 4, then we get 3 times 4 plus 1. So the remainder is 1, the quotient is 3. So we may rewrite the negative 13 pi over 4 as the negative 3 pi and minus the pi over 4, right? So you may continue to rewrite this as the negative 2 pi minus pi and then minus pi. So you can sketch this angle so negative 2 pi, 1 revolution clockwise, and then you have pi and then pi over 4, right? So the reference angle for this negative 13 pi over 4 is pi over 4. So this guy, that is the pi over 4. Then we know sine of the negative 13 pi over 4 should be equal to sine of the reference angle pi over 4 up to a sine, S-I-G-N, right? And we know in the quotient tool, sine of theta is positive. So that means we may just prefix a plus sign here, right? And this is how we get the sine of the negative 30 pi over 4 equal to sine of pi over 4. And this is how we go without this 30. Got it? Another question is about the amplitude. So when we draw the graph of a sine function, right? And we know the maximum of this sine function is 1. And the minimum of this sine function is negative 1. So the amplitude generally is defined as the half of the absolute value of the maximum minus minimum. So for this one, the function is y equal to sine of x. So its amplitude is equal to 1/2 times 1 minus negative 1 and then equal to 1. So actually later we just see if we have the sine function y equal to a times the sine of x, right? Y equal to the a times sine of x. Then its amplitude is just equal to the absolute value of this coefficient. So that is equal to absolute value of a. Some guys ask me how I get the amplitude of this function in the problem 8. So right now, this coefficient of this sine function is equal to 1. So its absolute value is equal to 1. So the amplitude for this function is 1. Similarly, if you have the cosine function y equal to a times the cosine x, then the amplitude is also equal to the absolute value of this coefficient a. Okay. Now let's come back to the problem 20. So for this one, the coefficient of this cosine function is equal to 1. So its amplitude is also equal to 1. And when we draw the graph of the sine function, we take the 5 key points. Actually, we just draw the sine function in the fundamental cycle. We know the period of the sine function is 2 pi, right? So we have the 2 pi here. Now how do we find all those 5 key points? We first find the middle point of the 2 pi and the 0. Then we have the pi here, right? And then we find a middle point between the 0 and the pi. So we get a half pi here. And we find the middle point between the pi and the 2 pi. So that is the 3 pi over 2. Then we use these 5 values as the values of x. Then we compute the corresponding y value. So that is the unit x. Take these 5 values. Then you compute the corresponding y equal to sine of x. So that means when x is equal to 0, you plug in this x. You plug in this 0 into the sine for x. So you have the sine 0 equal to 0. And when the x is equal to half pi, you plug in this half pi into the sine for x, you get the sine of half pi, so that is equal to 1. And then when the x is equal to pi, you plug in this pi into here, you get 0 again. And then 3 pi over 2, so get the negative 1. And then 2 pi, then equal to 0. So in this way, you form the 5 key points. That is the 0, then the corresponding y coordinate is 0. So you have the 0, 0. Just pair these two numbers. And then half pi, the corresponding y value is equal to 1. So you get the half pi 1. And then pi 0. And then 3 pi over 2, negative 1. And then 2 pi 0. And when you plot these 5 points, you may use the approximate value for the half pi. Half pi approximately equal to 1.57. So that means you may just use the 1.57 as approximate for this half pi. And similarly for the pi 3.14 and 3 pi over 2 and 2 pi. Then you plot them in this way. Say this is your 0, 0, and then this is your half pi 1, and this is your pi 0, and this is your 3 pi over 2 and negative 1, and then this is your 2 pi 0. Then you use the smooth curve to connect all those 5 points. Then you get sine wave, right? Another question is about